Hello students, this video is brought to you by Southern Pathshala. MCQs on magnetism and matter. Which is true regarding a bar magnet? The magnetic field lines are directed from south to north outside the magnet. Okay, which is not true regarding the magnetic field lines. Normal to the magnetic field lines gives the direction of magnetic field. Only the tangent will give direction. Product of area of current through the current loop is called as, that is, magnetic moment. M is equal to I into A. Magnetic field at a distance r on the axial line on magnetic dipole is given by B is equal to mu naught by 4 pi 2m divided by r cube. Therefore, it is inversely proportional to r cube. Next, the magnetic field at a distance r on the equatorial line is B is equal to mu naught by 4 pi m divided by r cube. Therefore, it is also inversely proportional to r cube. Magnetic field at a distance on the axial line, this just now described is option B. Magnetic field on the equatorial line, that is B is equal to mu naught by 4 pi m divided by r cube. Product of pole strength and the length of the bar magnetic dipole is called as magnetic moment, that is M is equal to Qm into 2L, where Qm is the magnetic pole strength. Ratio of magnetic moment of the to the length of the magnetic dipole is called as pole strength, that is M divided by 2L is equal to Qm. The SI unit of magnetic pole strength is, that is SI unit of magnetic dipole moment is ampere meter square divided by length is meter. Therefore 1 m cancel, it will be ampere meter. The period of oscillation of the magnetic needle in a magnetic field depends on all the above. Okay, all the above. It is given by T is equal to 2 pi into root of I divided by m into B, where I is the moment of inertia. Okay, next question. Torque acting on a magnetic needle placed in a magnetic field is maximum when the magnetic moment and the magnetic field are perpendicular, because it is given by tau is equal to mb sin theta. Magnetic needle placed in a magnetic field will be unstable, so unstable equilibrium. For that we have to use the magnetic potential energy U is equal to minus mb cos theta. If theta is equal to 0 degree, then you will get U is equal to minus mb, so it will be a stable equilibrium. Okay, then magnetic needle placed in a magnetic field will be unstable equilibrium when theta is equal to 180 degree. Potential energy of the magnetic dipole with its magnetic moment aligned at an angle is given by U is equal to minus mb cos 90 degree, that is a perpendicular. Then you will get a answer 0. Okay, for this one. Potential energy stored in a magnetic dipole placed in its magnetic moment m inclined at an angle in the external magnetic field is given by U is equal to minus mb cos theta. The net magnetic flux through any closed surface is given by Gauss law, that is equal to 0. That is Gauss law statement. Gauss law says that the net magnetic flux through any closed surface is 0. The Gaussian surface is enclosing a magnetic dipole. Select the wrong statement. Okay, if you read here, the wrong statement will be net magnetic flux through the surface is unity, because answer must be 0. Magnetic inclination, that is dip, is an angle between earth magnetic field and its horizontal component. Okay, next question. Magnetic inclination is the angle between the geographic meridian and the magnetic meridian. Inclination is maximum at the poles, inclination is minimum at the equator. What is the value of horizontal component of the earth magnetic field at the place where inclination is 90 degree? Horizontal component is given by BH is equal to B cos theta. 90 degree means cos 90 degree is equal to 0. Therefore, it will be 0. Answer is equal to 0. What is the value of vertical component magnetic field at the place where inclination is 0 degree? So, vertical component is BB sin theta. Therefore, it will be 0. Horizontal component of Earth's magnetic field at a place is 0. Angle of dip is nothing but it is 90 degree. Vertical component of the Earth magnetic field is 0. The angle of dip is nothing but it will be 0 degree. If ZE is the vertical component and HE is the horizontal component of the Earth, then the magnetic field is given by B is equal to root of BH square plus B square. That is nothing but the correct answer is option C. ZE square plus H square to the power 1 by 2. If ZE is the vertical component and HE is the horizontal component of the Earth's magnetic field at a place, the tangent of the inclination is equal to, tangent is tan theta is equal to BB by BH. So therefore here B is nothing but ZE, therefore it is ZE by HE. If ZE is the vertical component of the Earth magnetic field and BV is the Earth total magnetic field at a place, then ZE is equal to BE sin theta, vertical component it is. If HE is the horizontal component, then HE is equal to BE cos theta. Okay, so next question number 32. Net magnetic moment per unit volume. It is nothing but magnetization. Definition. SI unit of magnetization is ampere per meter. Okay, magnetic intensity is the ratio of magnetic induction to the permeability. SI unit of magnetic intensity is ampere per meter. Magnetic permeability is defined as the ratio of magnetic induction to the magnetic intensity. SI unit of magnetic permeability is Tesla per ampere meter. The ratio of magnetization to the magnetic intensity is called as magnetic susceptibility. The relative permeability mu r and the susceptibility chi of the magnetic materials are related as mu r is equal to 1 plus chi. Okay, dimensions of a susceptibility is a dimensionless physical quantity. Therefore, answer is M0, L0, T0. Dimension of relative permeabilities, again it is also a dimensionless physical quantity. Therefore, it is M0, L0, T0. Relative permeability mu r, absolute permeability mu, and the permeability of free space mu naught are related as mu is equal to mu r into mu naught. Absolute permeability mu, susceptibility chi, and permeability related as mu is equal to mu naught into 1 plus chi r. Okay, next, magnetic declination is the angle between. This is we finished. So next question, question number 44. Identify the property exhibited by the diamagnetic substance. They are repelled by the magnet. Magnetic materials whose susceptibility is very low are called as paramagnetic substances. Magnetic material whose susceptibility is high and positive are ferromagnetic materials. Magnetic materials which show hysteresis property are called as ferromagnetic materials. Magnetic materials whose susceptibility is inversely proportional to temperature, they are either ferromagnetic or paramagnetic substance because they obey Curie's law. Okay, the property exhibited by the diamagnetic material is called as Meissner's effect. Okay, perfect diamagnetism. Okay, Meissner effect is the phenomena of perfect diamagnetism in superconductors. Which is the diamagnetic material among the following? Okay, copper is a diamagnetic material. Iron is ferromagnetic, cobalt is ferromagnetic, nickel is a ferromagnetic. So copper is a diamagnetic. Which is the paramagnetic material among the following? Aluminium is the paramagnetic material and all these are ferromagnetic material. Which is the ferromagnetic material among the following? That is, iron is the ferromagnetic material. Superconductors are perfect diamagnets, therefore they are diamagnetic materials. Curie's law for a paramagnetic substance states that susceptibility of a paramagnetic material is inversely proportional to temperature. Soft magnetic materials are those in which the ferromagnetic materials which lose magnetization on removal of external magnetic field. Soft magnets. Hard magnetic materials are those whose ferromagnetic materials retain magnetization on removal of the external magnetic field. Curie's temperature in a magnetization is the temperature above which ferromagnetic material shows the property of ferromagnetic material. Retentivity of a ferromagnetic substance is the property of retaining magnetization when the external magnetizing field is removed. Coercivity is the property of losing the magnetization when external magnetic field is reversed. For a magnetic material, magnetic induction lags behind the strength of the magnetic intensity. This phenomena is called as hysteresis. Okay, next question number 62. Substance which at room temperature retain their ferromagnetic property for a long period of time, they are called as permanent magnets. Material used for constructing electromagnets must have high permeability and low retentivity. Materials used for constructing permanent magnets must have high permeability and high retentivity. Core of the transformer must be a material of high permeability, low retentivity and low hysteresis loss. Intrinsic magnetic dipole moment of atoms of diamagnetic material is 0. Intrinsic magnetic dipole moment of an atom of ferromagnetic material is very small. Intrinsic magnetic dipole moment of atoms of ferromagnetic material is large. Core of the electromagnets and the solenoids are made of soft iron. Area inside the hysteresis curve represent energy dissipated per unit volume. Thank you. Please subscribe Southern Pathshala for more such videos.